Hello everybody, in this presentation I would like to show you about the exoplanet. There are two people that work on this topic. One is Alice, who did the research, and me, Kit, who is in charge of the presentation. So moving on to our table of content, we have divided our topic into 4 parts. First, we will discuss about what are the exoplanets. Second, we will talk about a planet called Kepler 452b. Third, we will discuss about its host, named the Kepler 452. And last, we will end with a conclusion. To begin with, the first part of our topic, we have the question, what are the exoplanets? All the planets in our solar system orbit around the Sun. The planet that orbits around the other stars are called exoplanets. They are very hard to see directly with a telescope and are hidden by the bright glare of the stars they orbit. So astronomers use the other way to detect and study these distant planets. They search for the exoplanet by looking at the effects these planets have on the stars they orbit. Next, what are Earth analog? Earth analog is a planet or a moon with environmental conditions similar to those found on Earth. Using the mathematical model to plot the size and orbital distance for all the potential planets spotted, astronomers extrapolated the data and calculated that 1.4 to 2.7% of the Milky Way Sun-like star may have an Earth analog. 2% of the Milky Way, roughly 100 billion Sun-like stars, which means that you have 2 billion Earth analog planets in every galaxy. These work are done by the retired space telescope launched by NASA named KEPLER Space Telescope. Its objective is to find a planet that has the same size as Earth. NASA and exoplanets. How did they find one? One way to search for exoplanet is to look for a wobbly star. A star that has planet doesn't orbit perfectly around its center. From far away, this off-center orbit makes the star look like it's wobbling. Hundreds of planets have been discovered using this method. However, only big planets like Jupiter or even a larger planet that can be seen this way. Smaller planets like Earth-like planets are much harder to find because they only create a small wobble that are hard to detect. The sweep of NASA Kepler mission searched for a small, habitable planet in the last 6 years. The first planet, smaller than Earth, was called the Kepler 20e. Was discovered in December 2011, orbiting a Sun-like star, slightly cooler and smaller than our Sun in every 6 days. It is scorching hot and unable to maintain an atmosphere or a liquid water ocean. Kepler 22b was announced in the same month as the first planet in the habitable zone of a Sun-like star, but it is more twice the size of Earth and therefore unlikely to have a solid surface. After 3 years, Kepler 186f was discovered in April 2014. It is the first Earth-sized planet found in the habitable zone of a small, cold, and dwarf star, which has half size and mass of a Sun. Kepler 452b is the first near-Earth-sized planet in the habitable zone of a star very similar to the Sun. In this slide, there are some potential Kepler Earth examples given below in the picture. 12 exoplanet discoveries from the Kepler that are less than twice the size of the Earth and resides in the habitable zone of the whole star. The size of the exoplanet are represented by the size of each sphere. These are arranged by the size from left to right and by the type of the star they orbit. From the size M star that are slightly cooler and smaller than the Sun, to the size K star that are somewhat cooler and a bit smaller than the Sun, to the size G star that includes the Sun. The size of the planet are enlarged by 25 times compared to the stars. The Earth is shown for reference. Now, let me introduce you guys to the planet that is most similar to the Earth, that is the planet named Kepler 452b. In this slide, we have the comparison between the solar system of the Kepler 452b and the Kepler 186 and our solar system. This could be the reason why the planet Kepler 452b is the most similar to the Earth. In the picture, the topmost system is the Kepler 186. In the middle, it is the Kepler 452 system, and below is our solar system. We could see that the Kepler 186 system is a miniature solar system that would fit entirely inside the orbit of Mercury. The habitable zone of Kepler 186 system is very small on being compared to that of the Kepler 452 or even our solar system. It is because it's much smaller and a cooler star. The size and extent of the habitable zone of the Kepler 452 is nearly as the same as that of the Sun, but it is slightly bigger because the Kepler 452 is somewhat older, bigger, and brighter. The size of the orbit of Kepler 452b is nearly the same size as that of the Earth at 1.5 AU. Kepler 452b orbits its star once in every 385 days. Next is some characteristics of the planet Kepler 452b. Kepler 452b is in the constellation of Cygnus, which is about 1,402 light years from Earth. It is the first potentially rocky super-Earth planet. A rocky super-Earth planet is an extrasolar planet with a mass higher than Earth, but substantially below those of the solar system ice giants, which are Uranus and Neptune, which are 14.5 and 17 times Earth's respectively. The term super-Earth refers only to the mass of the planet, and so does not imply anything about the surface conditions or the habitability. The other term for super-Earth are gas dwarfs and mini Neptunes. If we would like to travel to the planet Kepler 452b, with the present technology, the speed of the New Horizons space aircraft, which is the fastest current space aircraft found on Earth, which has a speed of 59,000 kilometers per hour, it would take approximately 26 million years to get there. We don't know whether life exists on Kepler 452b, but we do know that it has something in common with the Earth. For instance, Kepler 452b takes 385 Earth days to complete its orbit around its star, which is only a bit longer than one Earth year. Astronomers say that the planet is in the Goldilocks zone, meaning that the distance of the planet from its star is just right, making it not too hot and not too cold for life to exist. The same is true of the Earth in our own solar system. Venus is too close to the Sun and is hot that water would boil up. Mars is too far away from the Sun and is so cold that water freezes. But Earth and Kepler 452b are both at just right distance from their stars, so that water could be in a liquid state at a temperature between 0 degrees Celsius and 100 degrees Celsius. Next, let's talk about the mass between the two planets. In the picture, it is the size of the Earth comparing to the size of the Kepler 452b. Astronomers have also managed to measure the size of the planet Kepler 452b. They can do this because the planet passes in front of its stars once every orbit as seen from the Earth. When the planet does this, it blocks a small part of the star's light so that it gets a bit fainter for a few hours. By measuring the amount of the dip in light, scientists have worked out that Kepler 452b is about 1.5 times the size of Earth. If the star Kepler 452 was closer to us and therefore brighter, astronomers could measure how much it wobbles as it's pulled backward and forward by the planet orbiting it. They could then use that measurement to work out the mass of Kepler 452b. This is not possible, but we can still make a good guess about the mass of the planet. If it is made of rock like Earth, then the mass of Kepler 452b must be about 5 times greater than Earth. This would mean that the gravity on the planet is about twice as strong as on Earth, so you would weigh twice as much there as you do here, and it would be twice as hard to jump. For example, if you weigh 60 on Earth, on the planet Kepler 452b, you would weigh 120. Therefore, it means that you are not heavy, but you're just in the wrong planet. Now, if we imagine us living on a Kepler 452b, how would our life be? With 60% wider than Earth and probably about 5 times more massive, its surface gravity is considerably strong that pulls the people are used to be here. Any hypothetical explorer would thus feel about twice as heavy on an alien world as they do on Earth. The Earth plant would photosynthesize just perfectly fine because how it orbits around its stars is at the same size as the Earth orbits its sun. Kepler 452b probably has a thick atmosphere, a liquid water, and active volcano, but these are best guesses based on the modeling work did by the scientists. Next, we will discuss about the Kepler 452 star, a host star of the Kepler 452b planet. Before getting to know the Kepler 452 stars, I would like to classify you some of the stars. In the shown table, there are different classes of stars shown. First, the O class, which the stars have the color as blue and on the surface temperature more than 25,000 Kelvin. An example is the 10 Anatrita star. This star is made up of the slightly ionized helium lines, either in emission or absorption, have a strong UV continuum. The B class star, which has also the same color, blue, but the surface temperature is around 11,000 to 25,000 Kelvin. Example is the Spica star. This star main characteristics is the neutral helium lines in the absorption. The next class of star is the A star, having same color as the above two stars, but the surface temperature of 7,500 Kelvin to 11,000 Kelvin. Example, the Sirius. Its characteristics is the hydrogen lines, strongest for the A0 stars and decreasing for the other A's. The next class of stars is the F stars, which have the color of blue to white. Surface temperature of 6,000 to 7,000 Kelvin. An example is the Canopus star. This star has the concentration of calcium absorption and metallic lines becoming noticeable. Next is our home sun star, which is the G class, having color of white to yellow and surface temperature of 5,000 to 6,000 Kelvin. An example is the Sun or the Kepler 452 star, which has the main characteristics of absorption lines of the neutral metallic atoms and ions. An example is one ionized calcium. The next class of star is the K star. which have the color of orange to red, having a surface temperature of 3,500 to 5,000 Kelvin. And the example is the Arcturus star. Its main characteristics is made out of the metallic line and some blue continent. The last class of star is the M star. The color is red, and the surface temperature is lower than 3,500 Kelvin. Example is the Betelgeuse star, which is made up of some of the molecular bands of titanium oxide. However, out of all the information, we are just focusing on the G-class stars, which are the home sun star of our solar system. Now, let's get to know about the Kepler 452. It is a G-type main sequence star located about 1,402 light years away from the Earth. It is present in the Cygnus constellation. Although similar in temperature to the Sun, it is 20% brighter, 3.7% more massive, and 11% larger. Along this, the star is approximately 6 billion years old and possesses a high metallicity. Thus, Kepler 452 can be considered as a solar twin, although it could be considered as a solar analog due to its age. Kepler 452 is approximately 104% the mass of the Sun and 111% the radius of the Sun. It has a temperature of 5,757 Kelvin and is roughly 6 billion years old. In comparison, the Sun is about 4.6 billion years old and has a temperature of 5,778 Kelvin. The star is metal-rich with metallicity of iron and hydrogen and of about 0.21 or about 162% of the amount of iron and other heavier metals found in the Sun. The star's luminosity is somewhat normal for a star like Kepler 452 with a luminosity of around 120% of that of the solar luminosity. The star's apparent magnitude, or how bright it appears from the Earth perspective, is 13.426. Therefore, it is too dim to be seen with the naked eye. In summary, between the Earth and the Kepler 452b, the Earth orbits around the Sun in 365 days, and Kepler orbits around its star in 385 days. One Earth mass is equal to 5 Earth mass on the Kepler 452b. The Earth temperature is 14 degrees Celsius, and on Kepler it will be minus 8 degrees Celsius. Both Earth and Kepler is in the habitable zone. One more difference is that the Kepler is 1.6 times the size of the Earth. And now we reach a conclusion. It is not clear if the Kepler 452b offers a habitable environment. Its orbit around the G2 type star, like the Sun, which is about 20% more luminous and with nearly the same temperature and mass. So far, thousands of planets have been discovered by the Kepler mission, and more will be found by the NASA transiting Exoplanet survey satellite, or called the TESS mission, which is observing the entire sky to locate the planet orbiting the nearest and the brightest star. We now know that exoplanets are very common in the universe, and future NASA missions have been planned to discover many more. Here is the source used for the presentation and for the information and research work. I will post the link in the comment below so that any of you guys who are interested to find more information about the exoplanet could use this link for further knowledge. Thank you.